Hey y'all, tell you what's going on today. I'm heading up on the hill at Landfill. This landfill, they only take construction waste and tires. And the way it works with these tires get buried in what they call cells. So the engineers have designed a certain way that they go about shredding these tires. They shred the tires come out of a tire shredder, they go into the back of a dump truck, they go to a cell, they get dumped into a cell, and they get placed there. So these cells that they build to put these shredded tires in, these dump trucks at times will basically be driving over top of several feet of tires. Well, they've had a problem with their Catapillar truck because there's a hydraulic line right above a drive shaft in that truck, where whenever the drive shaft gets a hold of a tire just right, it'll spin a tire around and it'll fling it up against this hydraulic line. It tears the hydraulic line off. Well, I was down here several months ago and I built them a skid plate to put on that truck. Well, they put that skid plate on that truck and it fixed the problem, totally fixed it. They haven't tore that line off since, and so that worked out really well. Now, what's going on now is the mechanic needs to get into that truck and replace a sensor, and he can't get in there because of that pan I put on there. So we're gonna have to take the pan off, and we're gonna see about what we got to do for that. They done fired this bad boy up here this morning, and I'm gonna get underneath of it and get some measurements. So we're shutting her down. I don't recommend just running to somewhere and jumping underneath a running piece of equipment. If somebody fires this thing up and runs you over, that's your fault for being stupid. Oh, here she be. Shout out to my boys. That's the skid plate that's keeping them tires. That's the skid plate that's keeping them tires from getting in that drive shaft right there and ripping that hydraulic line off. U-bolts the way they are, holding that on there. Now this machine's being leased, and on a leased machine we come up with that U-bolt idea just because we can't weld stuff on this. You know, Caterpillar's not going to want you to do that. So that was our solution, was to put the pan on it, but do it in a way that we're not welding anything onto the machine, any clips or anything like that. So after looking at that truck, looking at the skid plate and the U-bolts and talking to them guys, this is what I know. I had told those guys that after they ran that truck a little bit, they'd probably have to retighten those U-bolts to get them good and tight. That's generally the case with U-bolts. It's a good idea to let them jiggle around a little bit and then tighten them up again, and after that they'll usually stay tight. Well, those guys did that, but later, the U-bolts came loose again. And the theory that they have is that when that truck's driving in all this rubber, you know, and that rubber's rubbing against the bottom of that skid plate, they're thinking that in that one direction it's moving, it's actually the rubber that's looser than the nuts. And that could be possible, I don't know. But their solution for it was, the second time they tightened them, they tack welded the nut to the bolt. And when they called me recently and told me that they had to do that, and that the mechanic was going to have to get in there, and we were going to have to take the skid plate off, and they wanted new U-bolts so that they could take it off and put it back on, I thought, well, why didn't they tack the nut to the plate? Because I think if you tack welded the nut to the plate, you could take a grinder and grind the tack loose and still use the U-bolt. Well, now after looking at it, I know regardless of what you tack to what, that's not the case, because that rubber is wearing on those nuts so bad, I'm not sure you could get it apart without cutting it, even if it wasn't tacked at all. Honestly, it's wore those nuts to where some of them don't even look like nuts. That shows me that replacing those U-bolts and replacing those nuts is something that's just going to be a maintenance on that machine now. Because you're eventually, the way that's wearing, you're eventually going to wear enough of the nut off that, you know, it's going to come off on its own anyway. And that's fine. Those guys they're always keeping an eye on that anyways, because they said occasionally a piece of tire will get up above that skid plate, and they just, when the truck's shut down, they'll reach in and pull it out. The skid plate is stopping the pieces of shredded tire from getting in there and spinning around and ripping the hydraulic line off, and that's what it was intended to do, and it's doing that, and everybody's really happy about that. That hydraulic line on that thing, I think it goes to the transmission, so when they rip that off, that truck's down. Wherever it's at when that happens, it ain't moving from there until that line's replaced, and that line's expensive. So what I'm realizing is I don't have enough threaded rod to make those U-bolts exactly the way I made them the last time, because you could see in the video, the way I made them the last time is the whole thing is threaded rod that I've heated and bent into the shape of a U-bolt. Well, when I did that, I remember I went and got U-bolts then, or I went and got threaded rod to make U-bolts then, and there wasn't a problem getting enough rod at that time. It seems like now there is. We've checked around here locally, and we're not finding a whole lot of available 1-inch threaded rod. Now, I did find some threaded rod at one place where it was astronomically expensive, and we're not interested in that either, because after looking at this thing, I'm realizing that entire U-bolt does not need to be threaded. And the amount of threaded rod I have right now that I was able to obtain locally is plenty to make the amount of threaded U-bolt that we need threaded. So I'm going to choose another material that I have and use a different material for the parts of it that don't need to be threaded. And that's just, it's going to be another way to skin the cat, so to speak. We're going to end up with the same result, and we're going to work with what we got to get it done and get it done today. So I'm going to make them a new set of U-bolts. I'm going to give them the nuts for the U-bolts. I'm going to deliver them back to them, and they have a torch where they can cut the U-bolts off. They can reassemble it when the mechanic's done doing what he's got to do, and then they can tack it back together so that it doesn't come loose. So we're headed back to the shop and we're going to fabricate some U-bolts. All right. You might have noticed where I cut the first couple pieces and it really chucked that piece hard out towards the backstop right there. I changed my stop to like this. See, I'm contacting here and this is on a little bit of an angle. That fixed that problem. It's not violently throwing them out of there now. It's allowed that to roll out much better. I use a piece of soapstone sharpened like this. When I mark hot rolled steel, marking this galvanized, I'm using a Sharpie. I saw a video of a guy that marks hot rolled steel like this with a Sharpie. And these don't last. And they're expensive. I don't know why you would mark hot rolled with a Sharpie. Your soapstone's helpful too, because if you sharpen it this way, it gives you a straight edge. This is a straight edge right here that you can go by. So if you're marking something, you know, you got some shape, you're taking this piece you're setting it up against there. See how perfectly that's following that? Perfectly square. You buy this soapstone in a big box. I think there's 100 pieces in there, or maybe more than that. I don't know. When you buy it, it's a brick about that big. I started NBS welding in January of 2000. I use this a lot, and I'm on my second block. That's how cheap and long-lasting soapstone is. And you know, you get 1,000,000 pieces like this, half the time I chuck them in the rocks. Once they get, I keep them around sometimes just to draw and shit, or the neighbor kids will scribble with them. Quick note on marking, and I'm back to work. See, I got a black mark on this. This galvanized or zinc coated, being so silver, I'd use the Sharpie. Oftentimes when you cut threaded rod, no matter how you cut it, you may have a burr. Have a burr like this from where you cut it. Now, I didn't put a nut on it when I cut it off, but if you're doing it like, if you're cutting one and you're sticking it in a vise and cutting it with a hacksaw or a reciprocating saw or something, it wouldn't be a bad idea to go ahead and screw a nut on it and then cut it and then take the nut off. When you take the nut off, that would remove whatever burr you got, if it's a burr that's going to prevent you from putting a nut on there. Now, in the case I'm in right here with this, my saw has left a burr that I just basically don't want to leave there. That's a sharp burr that was left that actually the saw didn't cut off. So what I'm going to do, I'm going to take a nut. Now this burr's not going to prevent me, I don't think it's going to prevent me from putting a nut onto this rod. And if it was, or if it did, what I would do is I would try to go from the other end and see if I could get it there. But what I've been able to do here, obviously, I've got a nut on there. Now, to make these easier to start, not only would I like to get rid of that burr, but I wouldn't mind to bevel it a little bit. And you could do that with an angle grinder if that's all you got. I've got a 12-inch sander, so that's really nice. But what I'm going to do is I'm going to sand the end of this, and then when I take the nut off, when I get to the point where I'm near the end, it's going to take any burr that's left off, and then I know that nut's going to start back on there really well. I got my parts cut, and I've got a piece of angle iron that I tacked to the table here. That's what I'm going to use to help me get these straight to splice these together. this is about what my fit up's going to look like. And you would have a lot of people say, oh, you're going to splice that together without beveling it? Question mark? Yes, I'm absolutely going to splice that together without beveling it. This has to be done in a way that's economical. With the MIG welder and the 035 wire, I can reach down in there and I can make a weld that's just damn near full penetration. Probably wouldn't pass an x-ray, probably not 100%. But with experience, I know what it's going to take to do this job. This is the fastest, most economical way to do it. If I was to bevel all of these parts and try to make some sort of a pipeline weld on them without a one speck of pepper, a slag in the middle, it's no longer economical and it's no longer a feasible idea. I know what I'm going to do is going to be strong enough. I can make it work. And that's the way I'm going to go about putting these 8 parts right here together now. I want to show you something I learned with this, and I learned it because I was paying attention to what was going on. I had my ground clamp connected to this table the way that you normally would, and I had a piece of threaded rod and I had my round bar that I was putting together. Now, for some reason, my arc went through the threaded rod rather than the round bar. We can see evidence on the angle iron. Now, that didn't ruin that, but it's undesirable. I didn't want those marks on that thread, and I didn't want any damage to that thread, and it is something that's preventable. Now, if you'll notice, when I went to put this second one together, I moved my ground clamp. I put my round bar up here. I put my clamp like this. I put my ground right there. Now, most likely scenario is that the ground's going to go through here, and I'll start welding here and then come over. And after I did that, we got this result. No more arc burns on the threads. Just make a note of that, and we're moving on. Always say how I hate tools that you can only use for one use. I like multitasking tools. This is a welder's wedge, like a pipeline welder would have to wedge the gap in his pipe. It makes a great scraper. You'll often be able to use the wedge effect maybe underneath a part to get it positioned correctly. Really good tool to have as a welder's wedge. I'm going to give you a look at what one of these looks like tacked up. What you're looking at inside of there is pretty much 3 tacks. And I've reached in there very deep and tacked it together using the angle iron to get it straight. And you can see I've got a lot of area there where I can get a lot of good penetration. And I'm doing this, this is, utilizing the advantage
of that MIG welder being able to reach in there and reach in there with that wire and make that. I'll be welding these up on the welding positioner. This is a really nice tool for a fab shop. This is another thing where, you know, it gives you a little bit of an edge economically, because welding something like this together would take a lot of time if you couldn't turn it. Obviously with this machine, it's going to be a big time saver, and it also helps with the quality of the work and what you can fabricate economically. I can rotate this part and weld it. I'm going to be basically, it makes me so that I can take a weld that would normally be somewhat out of position and make it where it's perfectly positioned. I have a variable speed control. I can change the speed. I can make it turn as fast or as slow as I want. And this is the way that I'm going to be welding these parts. Now, another thing to consider on this, when you're welding, obviously there's a lot of weld spatter and it will stick to metal. I can see on the end of that there's a couple spatter balls, and one of the things people use is they'll use some sort of an anti-spatter. There's sprays and different stuff you can use. That stuff does work. Sometimes I'm a little upset with the way it tolerates heat, because it doesn't tolerate heat as well as I wish sometimes. It's as it melts on stuff, it still kind of sticks to it and it can leave a residue. So if you're using anti-spatter on a project where you're going to paint it, you better make sure you remove that, because you can get reactions like fish eyes and nasty stuff in your finished paint job if you don't remove all that anti-spatter. Now, like I say, I don't like tools that I can only use for one thing, and you probably won't find any anti-spatter around here, because anti-spatter can only be used for anti-spatter. I'll show you what I'm going to use. With an oxyacetylene torch, the acetylene, when you light it, I don't know how well you can see this. There you go. See that soot? That black soot is carbon. Steel doesn't stick to carbon. That's the reason why when we carbon arc with rods that are made of carbon. Those rods don't stick to steel. What I've done right here, in the oil field, we would call this smoking the threads. If we're welding a pipe nipple, a threaded pipe nipple that we've cut onto a piece of pipe to make a piece of pipe the length we want in the field, this is the way we would do it. We would take an oxyacetylene torch, we would fire up only the acetylene, and we would smoke those threads with that carbon. And that'll definitely make a tremendous difference in the amount of carbon, or in the amount of spatter that'll stick to those threads when we weld this up. And it won't have any negative effects really over here where we're welding. So let's do it. I'm going to show you what this looks like welding one of these out on the positioner. I don't regret showing you the smoke in the threads trick with the carbon smoke from that torch, but I did try one of these without smoking the threads, and I didn't get enough spatter on it to bother me. So I'm not going to smoke the threads on all of them. Now, if it was a critical application and you were really concerned with it, I would highly recommend smoking the threads to prevent spatter. I don't think there's going to be a problem in this application, so I'm not going to smoke the threads on all of them. Let's weld one. Changing direction. So I changed direction because when I ran that first very hot pass in there, I was doing it kind of in an uphill sort of a fashion, a really deep penetration cleaning action. Then I changed direction and ran the cap pretty much more like a downhill sort of a pass. And that gave me the ability to fill it up. Moving on. Tacking these up with a gap in them, and that's good for weld penetration. But another thing is when you're putting something together quick like this, and just pretty much something that eyeballing it's good enough, check a few measurements and make sure you're close. You need to have a gap in this so you can move it. You'll put one tack on that. If you don't have a gap in there and you tack it here and it needs to go that way, you're not going to be able to move it that way because this steel here is going to be pushing against this steel. If you have a gap and you tack it right here, you still are able to hinge it to get it right. So here's what we got put together. Those would be the two smaller ones for the rear. There's the two bigger ones for the front. We'll get these out to the landfill and call this one done. All right.